Hey, this is Vicky Gaines. Welcome back. We're doing transformations using matrices. We're doing reflections and rotations in this video. Let's learn something new. Modeling motion with matrices. You can transform shapes by moving them, flipping them, turning them, enlarging them, and shrinking them. If your shapes are graphed on a coordinate plane, you can use matrices to find the coordinates of the new image of your shape. Transformations that you can complete with matrices include translation, prior video, reflections, this video, rotations, this video, and dilations was in a prior video. Transformations. Draw a line from the term to the correct definitions. Translation. First one is sliding a shape to a new position. There we go. Match them up. Reflection is flipping a shape to get a new position. Rotation is turning a shape a certain number of degrees. And dilation is enlarging or shrinking a shape. Recall, what is a vertex matrix? A vertex matrix is a matrix that's created from the coordinates of the vertices of a shape. So our example right here is quadrilateral A, B, C, D. So 4 vertices. And they have the following vertices. A is at the point -1, 5. B is at the point 3, 4. C is at the point 4, 0. And D is at the point -2, 1. Vertex matrix can be created as follows. X values are going to go in row 1 and Y values in row 2. So point A was -1, 5. B was at 3, 4. C was at 4, 0. And D, the Y value, is 1, and the X value was -2. All the X values go in row 1, Y values go in row 2. That's our vertex matrix. This is a 2 by 4 because it is a quadrilateral. There are 4 vertices. And there is a graph of it. Reflections. How do you complete a reflection of a shape using matrices? So we can reflect over the x-axis, and there is our reflection matrix, and the subscript is x-axis because that's what we're reflecting over it. Capital R is for reflection. A 2 by 2 matrix. 1, 0 is in row 1, 0, -1 is in row 2. We can also reflect over the y-axis. So here is our reflection over the y-axis matrix. Row 1 is a -1, 0. Row 2 is 0, 1. We can reflect over the line y = x. That's our identity function. So we're reflecting over the line y = x. So y = x is our subscript. It shows us what we're doing the reflection over. And our matrix is 0, 1, 1, 0. So example 1, reflecting over the x-axis. So we are given a pre-image. A is at -2, 3, B is at 6, 6, C is at 4, -5. And it tells us all the steps we need to do to graph the pre-image and then do our calculation and get our new image. So the reflection matrix that we need to do, because we're reflecting over the x-axis, is 1, 0, 0, -1. All of our y values are going to change signs. Let's do point A is at -2, 3. Boom, there it is. B is at 6, 6. And C is at 4, -5. Connect them. So we are reflecting this over the x-axis. So if they are above the x-axis, they're going to go below, and if they're below the x-axis, they're going to go above. So here's our reflection matrix. That's the one for the x-axis. Our vertex matrix again, and I'm going to use Desmos matrix calculator to do my calculations. So I put the reflection matrix in A and the vertex matrix in B, and I'm just going to multiply them. I can just put AB, I could put A times B, doesn't matter, and it will automatically give you the image matrix. So A prime is at -2, -3, B prime is at 6, -6, and C prime is at the point 4, 5. So here we go. There's A prime, B prime, C prime. Connect the points, and we have our image after reflecting our pre-image over the x-axis. Example 2, we're now reflecting over the y-axis, and there is our transformation matrix that is going to cause us to reflect over the y-axis. We are given point A is at 5, 4. We're going to plot it. Point B is at 8, 0. We're going to graph that one too. And C is at 2, -5. Graph that one, connect the points. We're going to use the reflection matrix for the y-axis, which is -1, 0, 0, 1. We're going to bring down our vertex matrix, and I'm going to do my calculations using the Desmos matrix calculator. So I put in the correct reflection matrix in A, and B is the vertex matrix. A times B gives us our answer. So A prime is at -5, 4, B prime is at -8, 0, and C prime is at -2, -5. Let's graph those. A prime is at -5, 4. Great. B prime, -8, 0. C prime, -2, -5. There we go. That's a reflection over the y-axis. Example 3 is reflecting over the line y equals x, and we are given triangle ABC with the vertices that are listed in the top right over there and over towards the left. The line y equals x looks like this, and that is the line we're reflecting over. It's the identity function. All the x values and y values are going to trade places, and that's what this reflection matrix is going to do when you reflect over the line y equals x. So our original pre-image vertex matrix, A is at -7, 1, B is at 2, 3, C is at the point 0, -5, and we can combine them to make our triangle. Connect the points. Reflection matrix was 0, 1, 1, 0, and vertex matrix we just got from up above. I'm going to use Desmos matrix calculator, and I'm going to put the reflection matrix 0, 1, 1, 0 in A, and their vertex matrix in B. And we're going to multiply those two together. And here we go. So A prime's at 1, -7, B prime's at the point 3, 2, and C prime is at the point -5, 0, and we can graph those. There is A prime, 1, -7, B prime, 3, 0, C prime is at -5, 0, and there is triangle ABC reflected over the identity function, the line y equals x, and that is our image. Rotations. We're doing counterclockwise rotations. This is the matrix we would need to multiply using for a rotation of 90 degrees counterclockwise. And this is what that rotation could look like. Rotating 180 degrees clockwise and counterclockwise give you the exact same thing. So it doesn't really need to tell us clockwise or counterclockwise because we're going to end up in the same spot. Counterclockwise rotation of 270 degrees, we need to use this matrix. And there it is, counterclockwise. Now, if they tell us 90 degrees clockwise, that's going to be the same as 270 counterclockwise. Or if they do 270 clockwise, that's going to be the same as 90 degrees counterclockwise. So we don't have all those listed, but we can have some similar things happen. Example 4, rotating 90 degrees counterclockwise about the origin. Here is that rotation matrix. We need our original point. It says up at the top right, our pre-image is at the point 3, 2, 5, 7, and 8, 4. So we have ourselves a little triangle again. We are going to rotate 90 degrees counterclockwise. So here is our vertex matrix. Double check we're putting it in correctly. There's our rotation matrix, 0, negative 1, 1, 0. Throw in our vertex matrix. And now we need to find out what our image matrix is after a 90 degrees rotation counterclockwise. So I'm going to go and use the Desmos matrix calculator. Put in my rotation matrix and put in my vertex matrix and multiply them. And there we go. So A prime is going to be at negative 2, 3. B prime is going to be at negative 7, 5. And C prime is going to be at negative 4, 8. And there it is after a rotation of 90 degrees counterclockwise about the origin. Example 5, rotating 180 degrees about the origin. There is our rotation matrix. It doesn't specify clockwise or counterclockwise because they end up being in the same spot. There is A, B, and C. The pre-image coordinates are listed in the top right. Counterclockwise is going in that direction, and that's moving B to where it's going to end up. We could also go clockwise, and I did it from C, so that is where C is going to end up. Let's see, vertex matrix. A is at 3, 2, B is at 5, 7, C is at 8, 4. There's our rotation matrix and our vertex matrix. Putting it in Desmos matrix calculator, our rotation matrix is negative 1, 0, 0, negative 1, and our vertex matrix has the coordinates for each of the points A, B, and C in it, and we're going to multiply those two together to get our image. A prime is going to be at negative 3, negative 2. B prime is going to be at negative 5, negative 7. And C prime is going to be at negative 8, negative 4. And there it is after 180 degrees rotation about the origin, either clockwise or counterclockwise, either way. Example 6 is rotating 270 degrees counterclockwise about the origin. We're starting off with the exact same triangle. There's our rotation matrix. So there's A, B, and C. And we can make our vertex matrix just like we've done before. There's our rotation matrix and our vertex matrix. Putting it in Desmos matrix calculator, we can put in our rotation matrix first, 0, 1, negative 1, 0, and we're going to multiply it by the vertex matrix. So we can just type in A, B, or A times B, and there we have it. So A is at 2, negative 3, B is at 7, negative 5, and C will end up being at 4, negative 8. And there it is after a rotation counterclockwise 270 degrees about the origin. And we have now finished transformations using matrices, reflections, and rotations. This is Vicki Gaines. Until we see each other again, I hope you continue learning something new.